Thank you for inviting me to speak here tonight, Piero. Hello, everyone. My name is Gary Boodhoo. I, as Piero had mentioned, am a creative director and an interface designer who works mostly in the field of video games. I'd like to show you some examples of what I've been working on for the past 2 years. I opened up a Pandora's box and I never really came out of it. I call it Deep Dream Vision Quest. Oops, bear with me. So, like around 2015, and I'm sure a lot of people in this audience have seen this sort of imagery before. It was sort of flooding the internet with kitsch and craziness around 2015, and I looked at it and I immediately fell in love. I was amazed to see what looked to me like photographs taken from the psychedelic, from inside of the psychedelic experience, and they said it couldn't be done, and yet there it was. I just thought that this stuff was just, I thought it was crazy, quite frankly, and I didn't understand like how a computer could understand the inside of my mind, like so profoundly and so clearly. So, and this is what I did with it. After several steps, I'm kind of starting at the ending. This was actually, it began life as dashboard video that I had shot from my commute home at work. And you know, ever since I had been a little kid, I've worn glasses all of my life, and ever since I had been a little kid, I kind of wondered, is this all I'm ever going to see? And I was like 7, actually, and it wasn't that I was so jaded. What I really meant was simply that maybe everything that I would see was just a combination of all the patterns I had already learned to see. And maybe that's just how vision itself, how vision itself actually worked. And then I wondered, could there be images out there that nobody knew the patterns for? That's what I'm seeing in here. You can see the highway, but I'm also seeing what I like to call the cafe scene. It's an imaginary space. Bear with me, I'm actually kind of spazzing with the clicker just a little bit. But one question that people have always asked me when I show this work is, well, where did that cafe come from? Where did those images come from? So let me step backwards a little bit, and I'm going to dive into some of the basics of machine learning as I understand it and how it relates to my work. To be very clear, machine learning is an exploding field. It's very practical as well as very aspirational. I'm interested in all of that, but most of what I'm interested in is when the network gets the wrong answers. And that for me has always been the starting point for poetry. What we're looking at here is an artificial neuron. And I put it side by side with a picture of a real neuron, just to show the differences in complexity, basically. What we're looking at here, I mean, there's not much to say about artificial neurons. Basically, they take inputs, they add them together, they multiply them, they spit them back out on the other end. And by themselves, that really won't get you so much. However, they tend to be connected to one another in what are called neural networks. And this is a picture, actually, of what's called a multi-layer perceptron. And it is one of the very first neural networks that was invented. I believe the concept goes back to the 1940s. Alan Turing himself actually wrote papers on these toy perceptrons. And they're still used today. I mean, it really is, in many ways, it's the workhorse of the machine learning industry. And when I say connected, what I mean, I probably have a pointer, but I'm not going to fret it. It's just that those circles, each of those represents a neuron whose output is connected to the input of a next layer, and then that next layer contributes its outputs to a next layer, and it goes on and on and on. This is a very small network. Now the neural network itself they don't know anything until you train them to know something. And this diagram shows a very simple neural network. It's been trained to actually separate orange circles from blue circles. And you can sort of think of it as like pouring a box of marbles data into the big end at the top of it. That's what I call it, the big end. And it just sort of sorts itself out. Now, it doesn't do this on its own. Each of these iterations has a reward associated with it. And over time, it gets into the habit, as we all do, about seeking a reward. So for a simple network like this, it's actually very easy to gain like 100% accuracy. It's not complicated. It's a bit of a toy problem, quite frankly. But the one thing I kind of want to point out here is that each of these branches represents a separate neuron. And where we are seeing this filtering happening, we are seeing the decisions being made by a neuron, saying, hey, pass that signal along down the chain, or attenuate that signal and don't let it persist. So has anybody in here heard the term deep learning? Possibly today, possibly within the last 30 minutes. That term used to give me such trouble because as I was learning about machine learning, this deep learning thing came in, and I didn't know, is that the same thing, or is deep learning? Like, machine learning seems kind of, I just kind of assumed that deep learning, oh, that was the real AI that I had already read about. Machine learning was like old hat, but deep learning, that was the thing. It turns out, though, that the deep part of deep learning is quite literal. It has to do with the network architectures that are used. And just as we looked at the perceptron previously, where every neuron was connected to another neuron down the line, deep learning works, this is actually what you would call it's called a convolutional neural network. And these were designed specifically to analyze spatial information. In practice, that tends to be pictures, whether that's facial recognition, object recognition, machine hallucinations, that sort of thing. And you can see the stacks. This input, this is the big end. Pictures go into that. You can see these volumes are actually just slabs, layers of neurons arranged in three dimensions. And there is not a direct one-to-one correspondence between these layers. You can read more about the ins and outs of neural networks actually on my website, deepdreamvisionquest.com. But for me, the takeaway from this is that what a convolutional neural network really does is that pictures go in one end and words come out the other end. And in this case, red fox. And so, well, that's just a word, really, but where did that come from? Like, was the neural network able to just look at a picture and to somehow automatically assume, to realize, oh, there's a red fox in there? Red fox is an item in a list. These networks are trained on an image database, typically on about 1,000 different categories, at least the networks that are easily available to the open source community and to the academic community. And part of that is simply because if you're measuring the performance of network A versus network B, you want the data sets to be the same. And in fact, there are yearly challenges for the ImageNet large-scale visual recognition test, in which different organizations will score their networks against this basic metric. when we look at what a neural network is doing when it interprets these images, it does so from the big end, from the simple to the complex. Before it really knows anything, it learns about edges. How are objects separated from one another? How are angles separated from one another? And then it begins to understand textures. As it gets smarter, edges and textures combine into parts, and then finally into objects. And these objects correspond to the classes I was previously mentioning. And these are objects that the network was trained on. Just out of curiosity, I'm not sure how well everyone can see back there. Can anyone tell what that object might be?
Turtle's like a turtle.
It is. What's kind of crazy about it is one of a couple turtles in the data set is a loggerhead turtle. And what that means is that the network is able to distinguish between different types of turtles. But more specifically, the network is able to distinguish between turtle nests. These are visual concepts that are being represented. At no point was there ever a picture of a turtle in the network. It just has the habit. Given the right data, assuming you're training it on turtles, this is the sort of thing that falls out of it. And so, where did that turtle image come from? I mean, the network didn't just spit it out. Like, we had to do a bit of work to do that. This is a process, this visualization process is something that was started at Google back in 2015, just to really understand what's inside of our networks. They can be quite large. And the way that it works is that ordinarily, I don't know if you can, if you're able to tell, but I've flipped this diagram backwards. Ordinarily, we would feed an image into this, and we would get a classification out of this end. But we can run it backwards in the sense that we can feed in a classification, and what we do at that point is that we just give it like an image of static. I don't know if these images are actually starting. They're just it's just noise that it starts off with, and then we run the image through it backwards. We then listen to these neurons in this volume for which ones are being activated by the class. Let's say that it's class ID 13 in computer talk. Which of these neurons in this volume are being activated? And the ones that are, just add it back onto the image. And then we send it back through again. And after about 100 iterations of feedback, we start to see this class just emerging from nothingness, really. And this is how neural visualization is done. I actually think it's kind of magical. Technically, it's linear algebra, but it's magical all the same to me. So just out of curiosity, let's guess that class. Can anyone tell me what this is, what the neural network has recognized here? Yes. Did I skip ahead in my slide, or is it that obvious? It is a red fox. Let's do another one. Can anyone tell what this is a visualization of? So I'm hearing saxophone and I'm hearing jazz, and both are right. Specifically, it's a saxophone. One thing I found amazing about understanding the data inside the network this way was that, while yes, there is a saxophone-like structure there, it's clearly recognizable to us as our interpretation as a saxophone. It's come along with a lot of baggage from the real world that we didn't explicitly put in there. It's extracted that information from the millions of images of saxophones that it's seeing. One of those things is that, well, saxophones actually, usually with pictures, have saxophonists attached to them. And it's bizarre to me that it's gone ahead and sort of generated, like, can you see this face? Up here, it's generated this face, even though it's a face of nobody, but it's also clearly a man. And I can tell that he has short hair. And I can tell, to me, it seems like he's wearing kind of like a purple suit, probably hanging out, being super cool in a jazz club. And he has a soulful expression. I just think it's amazing that you can look at an image like this and infer a story about it. And it's not unique to us. It's actually inherent to the way that visual information is structured around patterns universal patterns that build up images from the ground up. Let's do one final one. Can anyone guess what this class is?
Bear.
It is a bear. And he has come along, well, you know, it's funny. It is the classification bear. Technically, it's a picture of bear-ness, is how I like to think about it. But how amazing it is to me that, well, his tongue is sticking out. He's probably eating some kind of grass. If you're up this close, you can see something that looks like a little mushroom over there. And in the background, there's something, at least to my eye, that looks like tree stumps and foliage. All of that has been brought in to the network. And this additional information is actually what my own work is very much about teasing out. Like that crazy cafe scene had so many details in it. It came from the baggage that came from the training. So we saw how to visualize classes from a convolutional neural network. The deep dream algorithm, honestly, is a bit more, I'll say, punk rock than that. It's not real specific. Like with the class visualizations, we can say, hey, give me the bear class, it'll give you the bear. Give me the saxophone class, it'll give you the saxophone. With deep dream instead, we take a bit more of like a sort of like a laissez-faire kind of, I mean, we're artists, damn it. We take like a laissez-faire kind of attitude, and we just say, hey, just maximize, imagining the neural network as like a big box. It would be gigantic, mind you. It would be much bigger than this room. Just kind of maximize the contribution of those neurons in this bit, like right over here. And if we don't like those, maybe we'll get these. Now you'll remember, this is backwards. This bit recognizes edges, this bit recognizes textures, this bit recognizes pieces of objects, and it spits out like a class. And so when we maximize this and send it back through a couple times, we're just taking this image, adding the neural contribution to it, sending it back through, and we do that in a feedback loop. And after about 100 iterations, it becomes a bit like dimethyltryptamine in the clouds, because that's just what happens when you do that kind of feedback. Now, what if you were to train a neural network perfectly? Let's say on foxes, saxophones, bears, but then you showed it the introduction to Star Trek, The Next Generation. So there's no way it's going to get anything right here. But what I thought was beautiful and what I thought was poetic, frankly, was how, even when it gets it wrong, like we understand the rightness of it. We understand why it thinks that space is velvet. I mean, it doesn't know space, but it does know velvet. And I mean, it does resemble velvet. Put yourself in the role of a computer. You've never seen Star Trek. You don't know what a starship is. There's so many things you don't know, but you do know CD players, crash helmets, hair dryers, and maybe a starship could be said to be an amalgamation of those parts. Taking those two concepts, class visualization and deliberate misidentification, I moved forward. Actually, I'm getting ahead of myself. Let me just kind of point out how that misdirection can play out visually. This is a technique called style transfer. This is actually done on a supercomputer, my computer, at home, but you can also do it on a phone using apps like Prisma or even Facebook, although it tends to be a lot less resolved. But unlike Deep Dream, it takes two images, a source image and a texture image, and it deliberately misunderstands this image in the context of this, which is to say it tries to reconstruct this image out of what it knows about this image. And we call that style. What's incredible to me is that as often as not, that really is what style is. And so it makes you kind of wonder, is style really just misdirection or poetry of things that you never really understood, but you put them together and maybe that's what it is, maybe it isn't. These concepts, though, of misdirection and of misinterpretation, I should say, and of class visualization led me to some interesting results. So I was in love with that when I first did that, like about 2015. It represented a bit of a pinnacle for me, where I was able to very deliberately apply, well, I can't really get into that, it's all on my website. But where I was able to get artistic intent. I wasn't just getting novelty out of the network, I was getting artistic intent and applying it to pre-rendered video. But you know, I felt that there was something missing from that. Jack Nicholson gets tons of exposure, I get almost none. And what I wanted to see actually was myself, and I wanted to see other people. So I went from a post-production, video production type of workflow, and into more of a game workflow, where it was very much about interactivity and feedback. Like, long story short, I attached a webcam to my neural network, and I showed it the world, which it promptly misunderstood in spectacular ways. This is one of my early tests when I was working on the renderer. It's being invoked by the motion of my hand in this mirror. When I stay perfectly still, the images that the network is generating just cycle and feedback upon themselves, and my living room becomes exotic. When I move my hand in the mirror, it recaptures that image, and that was the basis of the video installation work that I have been doing since then. So, I had shown this work, actually, a version of this work at the Game Developers Conference last year to a technical crowd, and it was very well received. But you know, again, I felt like I was still missing something. I was missing people, and in this particular case, I was missing a DJ, and I was missing a bar. There were a ton of technical people at this event. It was a Kodame Art and Tech Festival last year. It was actually just a few days after the election, so people's spirits were a bit low. And it was such a celebration of life. When people kind of walked in, there were a number of other people showing work at this event. I just found it so satisfying to see people reacting to it and playing with it. What I often find with this exhibit is that people will just kind of grok it immediately. They'll do something and they'll do something, and then they will see themselves, the reaction of the computer to themselves doing something. This is an encounter loop, what I'm calling an encounter loop, for my installation at the L.A.S.E.R Festival in San Jose a few months ago. One of the things I was experimenting with actually was the placement and just the stagecraft, the stagecraft of my production. In particular, instead of just going like a random TV on the wall, I brought in my own 50-inch TV. I mounted it to a media cart and I flipped it vertically and put the webcam on the side, such that the experience was that you would walk up to it as though it was a full-length mirror and would interact with like a slightly larger than life version of yourself. I was trying to increase the intimacy. It had lights on the side and so forth. And this woman in particular, she owned it. She actually won. She won Deep Dream Vision Quest. Actually, which I did not. Actually, there was a little kid who I didn't show who was the true winner. She came in second place. She leveled up. I just loved seeing her reacting to it, and to seeing that. I feel like my neural network also enjoyed. It is Gregarious, after all. It enjoyed seeing her as well. This was actually the night before that show, where I just actually had it setting up on a room with very little motion in it. My wife was there. We had two friends over there, but they were mostly just standing still, observing the craziness changing. And so what we're seeing here is just neural feedback. It's taking the image that it's outputting, and it's feeding itself, feeding the image like back into it. Every now and then you'll see a person because they just happen to move. It's difficult to stay aggressively still in that manner. So, what is next though? And it's a question I think about a whole lot of late, I have my rig. This is it here, the TV, the camera, the lights, and so on. It's very self-contained. I can take it anywhere, but I'm extremely interested in collaborating on this particular project, especially with large-scale projection, whether onto projection mapping architecture, which is to say deep dreaming the real environment and projecting that back onto the environment, or literally projecting on storefronts where people can walk by and all of a sudden be faced with creative machine intelligence, or as I just like to call it, creative intelligence, and to see what happens next. Well, thank you very much, everyone. Any questions?
We'll take questions later because Gary look more. Yeah, I see the light. Let's try to keep